Hey everybody, it's time for more on the liver. There's a liver right there. It's been sliced transversely. The liver's got a connective tissue capsule wrapped around it, anchoring it, holding it in place. Then that capsule sends in bits of connective tissue called septa. You can see all these light colored spaces in here, all these light colored areas. This is the connective tissue. It divides the liver up into about, I don't know, I want to say 10,000 or so liver lobules. This is one liver lobule here. The liver lobule does everything the liver does. So it's going to make plasma proteins, it's going to metabolize nutrients, it's going to make bile, it's going to do all that stuff. So what we got to do is get a close up, in-depth look at some liver lobules. We got 4 liver lobules. Each liver lobule is roughly hexagonal. Each liver lobule has a big vein in the middle called the central vein. Each has 2 blood vessels at every corner and a bile duct at every corner. Each has some rows of liver cells or hepatocytes and some sinusoidal capillaries, really wide open twisty capillaries running between the blood vessels in the corner and that central vein. Okay, so here's a chunk of a liver lobule. We took a piece of it. There's the central vein, there's the blood vessels at the corner. This is a portal venule taking blood that was in the hepatic portal vein. All right, so it's blood that could have a lot of nutrients in it, plus bad stuff, toxins, pathogens, whatever. And that blood gets emptied into this hepatic sinusoid, the sinusoidal capillary here. The blood flows past the hepatocytes so they can deal with the nutrients, deal with the toxins, pathogens, whatever. Meanwhile, there's a portal arteriole here carrying normal oxygen-rich blood. And these guys, the arteriole and the venule, they both empty into what amounts to be the same capillary. The blood here, of course, is red. It's oxygen-rich, bringing what the oxygen the liver cells are going to need. Now, this lets the liver do a lot of its blood modification jobs. These two vessels, the venule and the arteriole, they're going to bring blood to the lobule, let the lobule modify that blood in terms of nutrient pickup, in terms of detoxification, whatever it might be. And that blood flows through the capillary here, the hepatic sinusoid, into a central vein. Central veins then, of course, will combine, get bigger and bigger until we get the hepatic veins. They're going to leave the liver. All right, awesome. Got some questions for you to do here. I'll let you do those on your own. And one other thing to talk about with the liver lobule is all these little green tubes running between the hepatocytes here. These little green tubes are bile canaliculi. They're going to carry the bile that's constantly being made by all these hepatocytes, and that bile is going to flow outward towards the corner. Notice opposite direction, bile going this way, blood going this way, towards the bile duct out here. And that bile duct is then going to combine with other bile ducts from other lobules to get bigger and bigger, more bigger and more bigger bile ducts until eventually we've got the 2 that leave the liver, the right and the left hepatic ducts. Okay, speaking of bile, well, what does bile have in it? Bile has bile salts. Bile salts, here's the bile salt right over here. It's this chemical. It's going to have both hydrophobic and hydrophilic parts to it. So what that means is it can take a big old fat globule and separate it into many small fat globules. This process is emulsification. And the value of it is it's going to increase the surface area that's going to be available for lipases, fat digesting enzymes, to act upon. Bile also contains a heme byproduct, bilirubin. Good old bilirubin. So what you got to do is figure out then, why would a lack of bile secretion result in grayish, whitish poop? There'd be too much of something and not enough of something else. Let me know what you come up with. Okay, onward and upward to the gallbladder. There it is, right there. Sitting nestled kind of in the right side of the liver. Its jobs are threefold. It's going to store bile. It's going to concentrate that bile. It's going to make it stronger, in other words. And then it's going to squeeze to excrete that bile out. Now, if we look at the histology of the gallbladder, here's the gallbladder over here. Notice the folds. So the gallbladder is going to have rugae, just like the stomach. This makes sense for an organ that's going to be a storage organ. If you're going to store bile, you got to be able to expand. Rugae let that expansion occur. Also, the epithelium in here is simple columnar epithelium with microvilli. Why microvilli? Well, we know microvilli give us more surface area. We need more surface area so that we can absorb water from the bile. Now, why are we going to do that? Well, that's going to concentrate the bile. That's going to make it more potent. All right, last but not least, check out this thick, smooth muscle muscularis down here. This is essential for the ejection of bile that has to take place, the squeezing of the gallbladder that we need to do when bile needs to go into the duodenum. All right, now we got to figure out what prompts that muscle to contract. Okay, actually got to do one other thing first. We got to see how bile actually gets into the gallbladder. All right, so here's our hepatic ducts up here. Right hepatic duct, left hepatic duct. Bile's flowing down them into the common hepatic duct. Into the common bile duct. Then right here it runs into sphincters. Sphincters are almost always going to be closed. So the bile starts to back up. Back, beep, beep, beep. Backs up into the cystic duct, into the gallbladder. All right? And to get out the gallbladder, the muscular wall is going to squeeze. Bile is going to shoot down the cystic duct, down the common bile duct. Sphincters are going to be open wide, into the hepatopancreatic ampulla, and out into the duodenum. All right, but what triggers that? Well, here's the deal. When fatty chyme comes into the duodenum from the stomach, the duodenal endocrine cells, remember there are duodenal endocrine cells, they're going to release the hormone cholecystokinin, or CCK. CCK is going to cause the gallbladder muscularis to contract. It's going to squeeze bile out. Bile is going to flow down. So the volume of bile in the gallbladder is going to decrease. All right. Meanwhile, the sphincter that wraps around the hepatopancreatic ampulla, I didn't say that right, the hepatopancreatic, there we go, ampulla, that sphincter has got to relax to open up. Okay, so that lets the bile out. Meanwhile, if the duodenum is dealing with chyme, the duodenum needs to tell the stomach, hey, stop. So CCK also tells the stomach, stop making your gastric juice. So gastric juice secretion is going to go down. Okay. Now let's move and talk about the pancreas. There it is. It's got a body in the middle. It's got a head that punches the duodenum. It's got a tail over by the spleen. Spleen will be over here. We see the big pancreatic duct in there. We know that joins with the common bile duct to make the hepatopancreatic ampulla, which is covered up by the hepatopancreatic sphincter. We knew all that already. So if we zoom in on the histology of the vast majority of the pancreas, we're going to see these little spheres, these little balls of cells. Each little ball of cells is called an acinus, plural are acini. So the cells in here are acinar cells. Acinar cells make enzymes, amylases, lipases, proteases, nucleases, things that will break down starch, fats, proteins, and nucleic acids. Then those enzymes flow into a duct. The duct cell adds a bicarbonate-rich and thus a basic juice. Because remember, pancreatic juice, one of its jobs is going to be to neutralize the acidity of the chyme from the stomach. So, enzymes made in the acini. Enzymes go into little ducts, medium ducts. Ducts add alkaline fluid. That pancreatic juice ends up in the main pancreatic duct, which goes into the hepatopancreatic ampulla and into the duodenum. All right, but how does that occur? All right, how do we stimulate that to happen? Well, fatty chyme, we just mentioned, causes the duodenal endocrine cells to make CCK. CCK not only acts on the gallbladder and the stomach. Remember, it tells the gallbladder to contract, tells the stomach to stop, tells the hepatopancreatic sphincter to relax. CCK also makes the acinar cells secrete their